explain where I am. We're on page 23 in the packet, because I just set it to record, and so I got to do a quick backtrack. So we're on page 23 in the packet, just as a refresher. Did those ones there, so you can check that. And now we're here. Okay, so you tell me, what are we coming up with for A? Okay, and then you could write whatever that percent is. Okay, firstborn. Okay, good. Now, question on C. What is your denominator? It is still 223, because what's the probability that a person, you're pulling from all people, so all students, is, so there's your verb, and then that's your what's on top. That's your numerator, what's on top. Okay, so what is that numerator on top? The 15. Okay, and D is the same way. What's the probability that the person, so you're pulling from all of them, firstborn or human ecology. That is 141. So there are two ways you can come up with that. You can either, so here's what we have, this here and this here. I can say 113 plus 43, but if I do those totals, what happened with this 15? It overlapped and it got counted twice. So I would have to subtract one of the times that it got counted. Now, there's another way you can think of. Anybody else think of it a different way? Okay, how'd you do that? Good. You can say, okay, this total of 113 plus the remaining part of the human ecology that was not already accounted for. And that is coming from this piece right here, that 43 minus 15 is that 28. Okay, so they're equivalent. All right, good. Okay, go on to the next page. All right, so here we go on the next page. Okay, we got death penalty and your political party. Now, ultimately, I actually want to add another thought up here. I want to know, ultimately, does the political party, are the political party and your death penalty choice independent of each other? Okay, this is where we are headed today. Are they independent of each other? Okay, so let's go ahead and put these totals in here if you had not already. Which of course totals to 1. Okay, so here we go. And when I say our political party and death penalty choice, are they independent? What I'm basically saying is, if the fact that you are one thing, like if the fact that you are a Republican, is that changing the rate at which you favor or do not favor the death penalty? Okay? That's ultimately what we want to know. In fact, I'm going to ask that question here shortly. I'm going to say, given, do you remember this from before we had break? Given that you are a Republican, is that going to change the rate at which you favor the death penalty, or is it the same as those that favor the death penalty overall? Okay, this is where we are ultimately going today. Yes?
So I would think it would be the other way around, that whether or not you favor or oppose the death penalty from what political party. Which political party you're a part of depends on your political.
Well, I think you can use either way, and here's an example of this particular way. If I was a law student or a law assistant, and we were picking juries, the cases are typically won and lost with the juries that you select. I mean, a large portion of them. I'm not going to say all of them. Are won or lost with the jury that you select. Now, if I'm the defendant and I know that I kind of feel that I'm going to be having a guilty person, or we're in the sentencing phase, I might, if I find out that Republicans are more likely to favor the death penalty, I can look at voting records and I can see if my jury is highly Republican, then I have a more or less, or do I have the same probability that they're going to favor the death penalty penalty for my client. Okay, so that might be a case in where it would go, what's this party status telling me about their favor of the political party? Correct, and you could go either way on that, depending on what you're trying to determine. Okay, you can, I'm not saying which one is determining the other. I'm not saying which one's the X variable and which one's Y. Okay, all right, here we go. So straight up, what's the probability randomly chosen voter favors the death penalty? So overall, 62% favor the death penalty. Okay? And so we're wondering if the fact that you are Republican changes the rate at which you favor the death penalty. Okay, independent, independent, independent. Does the fact that you are Republican change the rate at which you favor the death penalty? Okay? Which sounds a little silly with this little children's song, and we're talking seriousness of death penalty such. But here we go. Next. What's the probability that a Republican, so that means now I have narrowed my bag down to what? This is a given that it's a Republican. What's the probability that they favor the death penalty? Okay? Per stuff that we learned before break, how do I compute this? Out of all the Republicans, so if I look up on voting records that this person is a Republican, then what's the likelihood they're going to be favoring the death penalty? See? So what's this favoring the death penalty and Republican intersection? 0.26. This makes it, I think, like 87.6%, somewhere around there. So here's my question. Those are not equal. Is the fact that you're a Republican changing the rate at which you favor the death penalty? Yes, so, knowing that you're a Republican gives me more information about your preference of the sentencing for my client. Okay? So would you say party and death penalty choice are independent of each other? Good, they are not independent. As the fact that you are one political party is changing the rate at which you favor the death penalty. Okay. All right, next. Find the probability that a voter who favors the death penalty, so what does that mean? I write this out. What am I given? Okay, good. I'm given that they favor the death penalty, which is your denominator, and then here are they Democrat? Okay, so your 0.62 is the favoring death penalty. What is the Democrat section of that? 0.12? Okay, so a much lower proportion of the ones that favor that are Democrat. I don't even know what that is. Okay, how are we going to do this? Candidate thinks she has a good chance of gaining votes of anyone who's Republican or in favor of the death penalty. What proportion is that? That's your 0.62 plus your Republicans, your death penalty plus your Republicans minus the overlap. And that's, how else could you do this one? Correct. Because these two together are that 0.04. Okay, which was up here your 0.62 plus the remainder of the Republicans. Okay, that is all I want to do on this assignment right now. And what I want to do is go to the page that I gave to you today, or that you picked up when you came in, that says Chapter 15, Part 3 Notes, Test for Independence, because that is where we started heading with this. All right, here we go. Chapter 15 Notes, Part 3, Test for Independence. Okay? All right. This is going to follow what we just had a discussion over. So I really kind of led you down this path with the discussion we just had. This is your gender having an influence on the model that you prefer, whatever that is, the version that you prefer. Okay? So here is information. This is pretty much this is kind of a formula that you have to have memorized. It does not show up on your formula chart. given, so here's given that one thing occurs, does that change the probability of the first event occurring compared to that first event overall? Okay, given that event 2 is happening, does that change the probability that event 1 is occurring compared to the probability of event 1 overall? So this is what you are questioning. If they are the same, then they are not affecting each other and they're independent. But if the fact that it is one thing does not change the rate, they are independent, okay? And the opposite for the other. Let's try this. Ready? Version B. What's the probability of version B here? Okay, 0.54. How about this, given that you're a male? The male portion is okay, so the male portion is the 0.4 is all the males. Okay? And what's the B portion of that males? That's your 0.18. This is actually 0.45. So what have we found? The fact that you are a male is doing what to your preference of version B? What's happening? Okay, let's envision this. Ready? I have my eyes closed. Somebody comes in here and stands before me, and you ask me, does this person prefer version B? Okay, so I have my eyes closed. Does this person prefer version B? And I'm like, okay, I don't know. I'm gonna guess yes because 54% of everybody prefers version B. Okay? But then you say, hey, Miss McClellan, I'm going to give you a hint. Guess what? This person is a male. And I'm like, okay, well now, okay, let's see here. Given that this person is a male, the probability that they prefer version B is less. So I think I'm going to switch that around and say it's less than 50%. So I'm going to switch it around. Do you see that? Given the fact, if the fact that they are male changes the rate at which they prefer version B. So here's how you do this little write-up. Is that independent or not independent? They are not independent, okay? So figure out how to write this little phrase. Not independent. Okay, so we're answering this question here. The fact that you are, and it's this thing right here, the given. The fact that you are, what? Male. Decreases the rate at which you prefer version B. Okay, so this is a perfect little write-up supporting your decision for independent or not independent. The fact that you are male decreases the rate at which you prefer version B. And then let's do numerical support. We've done that in the past. We did that at the beginning of the year. 54% versus 45%. Okay, remember that? Let's have you try one of these. Try example 2 on your own and do a little perfect write-up for it, and let's see how that goes. Okay, what do you guys think about that?
If you get the same number, no, I didn't get the same number, but if you do, they are independent.
Correct, and we're going to do that next.
Okay.
Yep. Okay, so they are not independent because the fact that you are female decreases the rate at which you prefer version A. And then I put the numbers. Yes, ma'am.
Do you know where the first one does this to the modifier?
It's always the fact that, oh, dang it, I wrote that wrong. Girlfriend, that's a stamp for you. The fact that you prefer version A, it has to be in that order. Yeah, I messed that up. The fact that you prefer this, because that's what you are given. The fact that you prefer version A decreases the rate at which you would be female. And know that sounds weird. It's not like you're changing your rate, but if I know that you are a person who prefers version A, then you are less likely to be a person that is a female. And that's wrong too, isn't it? Man, woo! Totally. Oh man, that's so bad, isn't it? Okay, let's go over this. You ready? How about I just totally start that one over? Boom. What is this saying? The probability of being a female overall is 60%. Oh, it is decreasing. And then if I know that you prefer version A, what's the probability of you being female? Less. Okay, so they are not independent because the fact that you prefer version A, sorry, does what? The fact that you prefer version A does what? Good. Decreases the rate at which you are female. And then you put your little numbers there, 60% versus 52%, okay? So I just shorthanded that because I was thinking I was messing up, but. All right, questions there? All right. Now, so without even doing any more of these problems, are gender and version independent variables? Okay, they are not. And we had two examples on the previous page to support that. Let's go to this problem. This is about blood type and your RH factor, whether you're RH positive or RH negative. I think in anatomy y'all are just talking about that. In fact, somebody was showing me a paragraph on that today. Apparently, if you are RH positive, then you have some kind of added antigen in your blood, and more people have that. I mean, that happens typically. But here's the deal: if you happen to be RH negative and somebody gives you blood that is RH positive, you have this extra added antigen in there, and your body starts freaking out and going, "Oh my gosh, there's this extra thing in here. I need to attack it." And so it starts attacking it, like your immune system starts attacking it, and it's as if, it's a foreign body in yourself. So if you're negative and they give you that extra added antigen blood, that's bad. Likewise, if you are a mama or a woman who's pregnant and you are RH negative, and say that your husband was RH positive, and then your baby that is in your tummy is RH positive, that's a problem. Because this is a mama who's negative, and she's got a foreign thing in her body that is RH positive. So what's the immune system going to naturally start doing? Attacking the baby. So you can still deal with that, but there's some special stuff, very, very special medical procedures that have to be done. And that's a very simplistic version, not 100% probably correct, because there's some other things other options and such. But so it's an important thing if you are RH negative that you kind of pay attention to that. All right. I wonder if your RH factor and the type of blood that you have are related. Are they independent of each other? I wonder, I'm type A blood, so I wonder if I'm more likely to be RH positive or RH negative or whatever. Okay? Let's figure that out. So, here we go. You ready? What are the marginal probabilities? That's overall. What's the overall probability of type A? Overall probability of type A is 0.42. Type B, 0.1. AB is 0.04. Type O is 0.44. RH positive. What are you doing? You're trying to mess me up? Okay. Gotcha. Okay. Now, I realize that there are answers all down there below, and you can see that and such, but I kind of want to go at this in a different way. If you look down here at the bottom, they say, given that you are RH negative or RH positive, does this change the rate at which you are a certain blood type? To me, blood typing is easier, so I want to actually ask this question differently. I want to know I'm type A blood. I want to know, given that I am type A blood, does that change the probability that I am Rh? Let's do negative because that's kind of the troublesome spot. Okay? So I'm thinking that, say, back in the day, 12 years ago, when I was thinking about having a baby and I'm thinking, I'm type A, does that change the rate at which I'm Rh negative? I need to watch out for that. Okay? So what goes here? Probability of what overall? Yes, Rh negative. This item and this item are the ones that are the same. Because I'm wondering if the fact that I am type A blood changes the rate that I could be Rh negative. Okay? So, let's do the math. Good. So, let's see. So, we're asking that question, are they equal? So, out of all the A's, what's the portion of the A's that are Rh negative? Correct. Okay? And guess what that ends up being? 0.15. Okay? So here's my question. Is the fact that I'm type A blood change the rate at which I could be Rh negative? The probability of me being Rh negative? No. Okay? So in this case, I really only have the right to say, is type A independent of Rh factor? Can't really make a blanket statement about all the blood types yet. Okay? So that's kind of annoying. If you get one of them that's wrong, then boom, you're done. You can say they're not independent of each other. But to say they are independent of each other, you kind of have to go through all of them. So let's split this up. Okay, you ready, class? I want this half, so we're going to go Heath to Connor over to the left. I want y'all to do type B blood. Okay? So you guys over here are going to go, given that you have type B blood, what's the probability of being Rh negative? Okay? We are ignoring the bottom, yep. So we're ignoring the what? Yeah, we're ignoring Rh positive right now. Because Rh negative is when you have problems. So that's what I'm interested in. Okay, I want the rest of the half over here, this right half, to do if you have AB blood. Okay, so find all that stuff. We're doing Rh negative because that's the problem. I'm going to do the type O right now while we're doing this. Then we'll have them all covered, okay? Do you see why you have to do them all if they're independent? Because at this point I only know A is independent, so let's do the others. Okay. So, you B people, type B blood people, what's your fraction made up of?
0.015.
Oh, that's easy.
That would be 1.1.
Okay, which makes 0.15. So, does the fact that you are type B blood change the rate at which you are Rh negative? No. fraction made up of? What? What? Ooh, there's not very many AB people. Okay, so was that 0.15? Okay, the fact that you are AB blood, does that change the rate at which you are RH negative? No. And the same thing for type O blood. All right, so is your blood type independent of RH negative? Yes, it's going to be the same for RH positive since there's only one other option, because then those are all going to be equaling the other part, which is the 0.85. Okay, so are they independent? Are they independent?
Yeah.
Good. Now, last thing, let's go to this other paper that you picked up.
So the only reason that they're independent is because one of them.
They're independent because all of them were the same. All of them were 0.15, 0.15, 0.15.
Okay.
Okay? So the fact that you are a particular blood type is not changing the rate at which you are RH negative.
Okay, I got it.
All right. Last thing. First of all, your homework is numbers 3 and number 4. So in this assignment, number 3 and number 4 is the homework. I will most likely not be here tomorrow because I'll be administering the end of course exam. So tomorrow in class, you're going to do number 5 and warm up chapter 15, and then we will quiz on Wednesday. Okay, so I changed that from what the original calendar says because of my absence. So let's look at this problem here. If I read this, if you're really smart, you might be able to keep all that stuff straight in your brain, but this is not something that I can keep straight in my brain, so I'm going to give you a technique. Okay, so let's read this. Here we go. A survey of CHS students found that 36% said that they would be interested in going to Saturn. Of those going to Saturn, 60% were not seniors. Of those who did not want to go to Saturn, 30% were seniors. Okay. I don't like keeping all that straight in my head. So here's the deal. Here's what I want you to recognize. If you come across a problem that says, if this, then that probability happens. But if this, then that probability happens. And if this, hey, you guys please, if this, then that probability happens. So whenever you have a whole lot of if this, then that, a tree diagram is the way to organize this. Okay? So here we go. We're going to start with all of the CHS students. Now, the way you know what to split it up first is the if this. So what would be the if this is? Is it if you are a senior, or is it if you're going to Saturn, then that? What is it? Which one is it? Okay, of those that want to go to Saturn, 60% are not seniors. So if you what? Want to go to Saturn. Okay, that's what tells me my first break off is the Saturn versus not Saturn. Okay, and that's 36% want to go to Saturn, which makes how much not want to go to Saturn? 64% of the students at CHS do not want to go to Saturn. All right, now, off of that breakdown, I do what? Good. If they are seniors or if they are not seniors. Wow. I understand that this is a silliness, and I should definitely change this in the future so you can get past the fact that this is absolute absurdity, okay? But just deal with it, all right? Here we go. So this is senior, and then this is not senior. All right, so let's say I've got 36% that want to go to Saturn, and what percent of that, what does this 60% go with? Not, okay. And then the seniors would be 40. Do you see that these two items right here are 100% of the 36%? So this is saying 40% of the 36%. How much is that then, in fact? What is 40% of 36%? You multiply those two together. You multiply 0.36 times 13.4, and that tells me that 13.4% of the overall student body are seniors that want to go to Saturn. Saturn is this new, totally hip skating rink. Okay, there you go. Now it's possible. Okay? All right. Okay, so then let's do our 60% of the 36% that want to go to Saturn are not seniors, so what does that number come out to be? I think it's 0.216. Okay, guess what these two numbers total up to be, by the way? These two numbers total up to be the 36% that want to go to Saturn. Okay, now, next. If they do not want to go to Saturn, what do I know? Of those that do not want to go to Saturn, what does it say? 30% are seniors, which would make what? 70% not seniors. So that is the portion of the not going to Saturn. Too good to go roller skating. Okay? So 30% of 64%, how am I going to get that total? That number? Multiply those two together, I get 192, and this one I think is 0.448. Guess what these two things total up to be? 0.64. Guess what all of that totals up to be altogether? 100% of the students at CHS. Okay? All right. So now I'm going to give you a second and let you answer questions A, B, C, and then we'll talk about D and E. So answer questions A, B, C for a minute. Okay, so what's the probability that a randomly selected student wants to go to Saturn? Okay, 36%. A randomly selected student is a senior that wants to go to Saturn. That's the 0.144. What's the probability that a randomly selected student is a senior? So that means I'm taking into account this section here and this section here. So that's the senior population, 0.144 and 0.192. That makes a total of 33.6% of the school being seniors. Well, it could be a 10th, 11th, and 12th campus, and aren't y'all the biggest senior class, so it's reasonable. All right. Now, how does question D change from this one up here, question B? It says student was randomly selected student is a senior that goes to Saturn versus D says randomly selected senior wants to go to Saturn. What's the difference? Good. The denominator is the difference. Here in part B, you were asking from 100% of the students, so 100% was the denominator. But here, it's what's the probability that they want to go to Saturn, given that they are a senior. Therefore, the denominator is the 0.336% that are seniors of the school. And the Saturn and senior portion of that is the 0.144. Okay? And that equals whatever that is. All right, so what do you think question E is asking? What's the probability that a randomly selected Saturn wannabe is a senior? So probability that they're a senior given that they want to go to Saturn. It's on the bottom. All the Saturn on the bottom and the senior Saturn ones on top. Okay, and that would be that, whatever that is. Well, it has 0.36 on the bottom instead of 0.336. They have different denominators, okay? They're close. I don't remember what those percentages are.
42.9% and 42.9%.
Good. All right, now fill in this table here. It should follow straight from your chart. See how that's going to fall in there, or from your diagram. Yes. No, because it is a given that, so it's given that they go to Saturn. That means I want to know if you know the fact up front that they're from Saturn. So that has to be the denominator. The 36% that are from Saturn. You mean just go? You mean just go this? Put this over that? Yeah. Oh. Huh. Okay, yeah. So then it gives you that. Okay, but the other one we can't do that way because there's not a senior section of the chart like that. So yeah, that one's kind of a little that's not typical. Doesn't happen always. Doesn't happen always. Okay. All right, back to this. Finish filling this in. Okay, I don't know. I've had so many of these numbers in my head today. Can't remember. Maybe that's right. I don't know. Okay. How am I going to figure out the students that were surveyed that fell into each one of those categories if 500 students were surveyed? Very good. Just multiply 500 times those probabilities. Okay, so do that real quick. Okay, now, ultimately, and I wrote this on your paper, what's the actual ultimate question that I want to be able to answer? Are they independent? Okay, so how can you figure that out? Okay, do you see that? That's my basic format. I need to fill in something and then test for independence. What you want to fill in? I don't care. Somebody tell me something right there. Senior or Saturn or whatever. Not senior, not Saturn. Okay, Saturn. And then what do you want to do over here? Not senior. Okay. Whatever. That's fine. What would go here then in this last section? Then that would be overall Saturn. Okay, so I know that's 0.36, so that's easy. Now I want to see if, let's see, what portion of not seniors? That's the, yeah, but I need percent. It's 0.664. And then the Saturn of that portion is 0.216. Okay, let's see what that is. Okay, I got 0.325. Okay, so are those are not equal, therefore, let's do one last final statement. Do I say that your grade level, senior or not, is independent or not independent of your choice of going to Saturn or not? They are not independent. Why? Let's do our little support phrase. The fact that you are what? Good. The fact that you are that thing right there, not a senior. What is it going to do? Okay, good. Okay, good. The probability that you want to go to Saturn. And that's decreasing from 36% 36% to 32.5%. Very good. Okay, so that's your deal. Now you have homework numbers 3 and 4. In my other classes, I got to number 2, but we did not in here. So you can just do numbers 3 and 4. What I probably will do is actually, when you guys leave, do the number 2, just so I have it completed on this video. If you need it, you're okay. Let me go ahead and do this last problem real quick, just in case you had some questions. So let me give you a second to read that problem and figure out to make your tree diagram. You first want to figure out what is the if this variable. So when the male students at CHS were asked, so in other words, if a student is male, then 50% of them said they do not date someone from CHS. If a student is female, okay, so your if then is the male versus female. So that is then, you start with all the CHS students. Why you would want to come up with this male versus female portion first. Okay, so let me give you a second to fill that in. I'm going to pause while you do that. All right, so there's your numbers, and so then when you multiply 0.52 times 0.5, you get your 0.26. Okay, so and then the next 0.48 times your 0.6 is the 0.192, and then the I don't think that's right. So let me double check that. Okay, yeah, didn't think that was right. 0.288, and the other one is your 0.192. Okay, so again, all of these ones here are going to total up to 100% of the students at CHS. So now, if I go and I put this in the table, then I've got this. Okay, so there's all my numbers. So now let's go ahead and figure out our questions. What's the probability that a randomly selected student, so out of all the students, does not date someone from CHS? Okay, so that would be this here, this 0.452. Student is a female. That would be all of that 0.48 that are females. Now, what's the probability of randomly selected student is, that's your verb, this and that. So that's the intersection of female and does not date. That's your 0.192. It is here, what's the probability that a student who dates someone from CHS, that makes your given that they date someone from CHS, what's the probability that they are male, goes this way. All right? Now, therefore, my numbers on the denominator is going to be that 0.5, what is it, 548 that date people at CHS. And of that, the 0.26 are the male portion of that. And so let's get that probability because we're going to use that here in a minute. Okay. And then, of course, you can fill in these other numbers by multiplying those above values. Okay, so I'm not going to actually do that part. My ultimate question that the goal that we're headed here is dating someone is gender, and dating someone at CHS or not are those independent events or independent variables. Okay? formulas. And I tell you what, because I already have a given that problem figured out here, I'm going to go ahead and put that here. Given that someone dates from CHS, what's the probability they are male? And that is 47.4%. Is that the same as being male overall, which is 52%? So are they equal? No. Therefore, in conclusion, we would say that gender and dating something, so those two things are not independent. And then I would say the fact that you date someone from CHS, so if I know you are dating from CHS, then you are less likely to be male. And that's 52% to 47.4%. Okay, so that's that. So now you are going to be doing numbers 3 and 4 for homework tonight, and we'll do number 5 and the warm-up in class tomorrow.